Hello, welcome. In the last video, we just covered the model classes and also implemented the enum classes and also configured the strategy pattern in our code and connected the strategy pattern with our interface. In this part, we will be going to cover the rest of interfaces we built in previous video, the repository and the IAuth strategy. In this video, we will cover the implementation part of the user repository. But as you know, as we seen in the last video, that we will cover the implementation part once its usage class is prepared, as the user repository will be used by the AuthManager. So today is that day in which we will build the AuthManager of authentication. And this day you will see real user registration in this code. Today is the actual compilation and clean run and execution of that code, which will be in the form of registration of the user. First, let's move the classes to their respective packages. Interface. So in interface, we have IAuth and user repository. So that will come in the interface part. And for user, there is a model package. Model class will be in model package. So there is auth token and JWT strategy. So we will decide it later. Now let's write. Now I have divided the repository and strategy in two parts. So let us now implement the repository of in-memory repository. As we have discussed in earlier videos that we are not using the real database here, as we need that our persistence decision will be the last decision we have. So we can actually see the actual implementation of interface and the implementation of that interface. So at the last, if we are using persistent solution at last, so we are able to see how the interface is loosely coupled with the actual data saving implementation of it. So currently we have the user repository as a interface, and now at this particular phase we are using the in-memory. Then in the subsequent after phases, we will use the SQL storage and more storage things in further videos. So now let us implement the in-memory. So to implement the in-memory repository, let us have the implementation class. Let us have the implementation class, which is in-memory user repository. So let us add it, and also let me implement it as a user repository. So it will implement the user repository. Now there is a red line which says to implement the methods which are in user repository. So click the implement methods. So we have to implement 3 of the methods which was available in user repository. So let me write 3 of the method. Now red line is gone. So for now, this is our repository. So add a repository. Now this annotation ensures that the Spring Boot will consider it as a bean. So we don't have to write and don't have to mention the exact object creation of in-memory user repository. The Spring will take care of it, as we don't have to manually write the in-memory user repository and make an object with a new keyword. The dependency inversion of Spring Boot will take care of it. So that's why we have used the repository as to denote that this class will belong to the data fetching or data accessing part of the Spring Boot. Now we can have the saving part. So where we will save the users, we need the user by email and we need the user by user ID. So let me make private. Why I am using the private? I am using the private because this particular variable is not accessible outside the class. And why there is a final? Because this particular variable will not have any new initialization. So this will have only one initialization. So particular like HashMap, we will have a string to save the user ID and then user. user by ID, I can say. User by ID equal to new. We will use a thread safe HashMap, which is concurrent HashMap. So let me keep as now I have this map, which is a interface, and this map contains two generic classes. So in generic, we have first RK and then other user. So this is user by ID, and why I have taken the concurrent hash map. Let me first create another hash map. So I'm creating another hash map for accessing with email. So currently I'm accessing with email, and to save it, we will save in user by ID dot put. What we will put? We will fetch from user dot get ID and the user. Okay. And also in another email, we will store it with the user dot get email and save the user associated with it. Now optional.empty, it has already returned that optional.entry, but we will return by ID. So we should see as to find by not email, find by ID. Find by ID. We must change in our user repository that it is find by ID, not email. We have renamed and renamed the users. So I have renamed the users. That's fine. Now, how to return an optional? To return the optional accessed by email, we should search the user on email HashMap. So dot get by email. So as a email is a key. Now, why there is a red mark? No argument. So the empty expects no argument, but we need to return. So we have AuthNullable. So AuthNullable will take care of your null part, as if we are not using the optional, we are missing out the things. As let's say we are only returning the user. So the caller needs to take care that it will not also use the always dot fetch directly. It should check before taking the values. So the optional is here to ensure that these things can also return null. So in the caller side, we can also use the user dot is present method to see that the value is present or it is a null value to just prevent the null pointer exception. So now in user part, we can also have optional as empty except no argument. So AuthNullable. Now in this we will find by ID. So get by not email, I need ID. So get by ID. Now let me change in user repository, it is ID. So now the most important part of this class, why we have used the concurrent hash maps. And there is another interview question, which is very important question. The interview question is on the screen I mentioned as, let us read it. If we mark this class as a Spring Bean, does that already make it thread safe? A lot of candidates say yes, because they remember that Spring Bean are singleton by default. But that answer is actually wrong. So let me answer this question as so. The answer is no. Applying a Spring Bean doesn't mean it is thread safe. Although it's guarantee about the singleton, but it's not a thread safe. So it is a singleton, but not thread safe. So why it is like this? Why it is not thread safe? Let me explain. So Spring Bean means whenever there is a Spring Bean on the class, so that means being a singleton, the Spring Boot will maintain a single instance of that class, but use it everywhere. And the Spring Boot does not guarantee that this singleton class is a thread safe class. So whenever we are saying that this class is thread safe, that means it should have only one thread going at a particular time. Now, in our case, the class is only singleton, not the thread safe. Let us take an example when the class is having a singleton feature, but inside that class, we have the hash map, although we have the concurrent hash map, but this is an example that if we are having only a hash map inside the singleton class and two of the requests came at the same time and want to change in that hash map, it can generate errors and exception and corrupt the hash map at the application runtime. So we can say clearly that the applying of the Spring Bean does not mean the class is a thread safe class. It is singleton, but it is not the thread safe. These are two different parts, being a thread safe and being a singleton. So do not mix it up. Otherwise, you will lose the score in your system design interview. Now the question arises why we are using a concurrent hash map. As we have told in earlier example that the simple hash map can lead to the corruption of the data and lead to the exception at the application runtime. So that's why we are using the concurrent hash map in our class. So concurrent hash map, what it says, why we are using it. So there are two reasons basically. One is it allow multiple threads to read. So there will be no time in reading because it allow multiple threads to simultaneously read. But the main thing is that it does not allow the multiple threads to write at the same time. So write safety at the same time without us writing a single line for manual locking code ourselves. So it provides the safety from multiple writings at the same time because it does not allow us to write locking mechanism ourselves. It have internal implementation of locking feature. So at the same example and at the same type of pace, you can crack the interview, and at the end you can say that the singleton nature of bean give us one shared instance and the concurrent hash map give us safety for the shared instance. So both of the pieces are important and neither one of it are enough because the singleton class provide us one shared instance and the variables inside it are the concurrent hash map that provide the safety for the that shared instance. So two of things are combined together and provide us the best safety and locking feature and one instance at the same time because in our book my show app there are many users concurrently can log in and can register. So to maintain the safety of hashmap, to maintain the safety of the in memory, we need to have the repository. So it will create a single instance and we need to have a concurrent hash map which will maintain the internal locking of the instances. So that's the reason of concurrent hash map and the reason of repository. So we have covered the two interview questions. So now let us move to AuthManager. So now this is the part 2 in which we will move to write the AuthManager class.